Touristy is a speech-to-speech AI that talks to you as you walk through the city. It helps narrate your journeys and gives you historical facts about certain areas, local history, and also helps answer questions along the way that you may have. We're pulling SF open data to showcase the health scores of various restaurants in the area. And also, we built
Touristy in action. So Touristy is a really simple app where you can explore like a local. Let's say I want to do a tour in the marina. So I'll be like, all right, let's start at Fort Mason Center. And we'll get a location, and all this stuff is ran locally. And as you see, I add this item right here, and it says stop number 1, and then we can go ahead and say let's do the Baker's Beach. There you go, Baker's Beach. And then from Baker's Beach, we are going to have Sutro's Bath. Okay, and then we do want to do Golden Gate Bridge as well. Okay, so you're like, okay, well, Kareem, this is kind of not the right order. We have simple functionality like this. We're like, all right, Golden Gate Bridge, just go up, up. Yeah, perfect. And then there you go. You can kind of make your own itinerary. And then we also have some fun AI features. Let's click on chat. And it was okay. Let's say you don't know much about SF. You want to just come into some stuff. So let's say I really like music. Give me some live venues, tour or something like that, right? And then this is all being run locally. These images that you're seeing are other creators who are logging into our app and making events. Tours. And you can see right here, our Nemotron is loading. And then we have a response. I'm glad you love music. San Francisco Live Music is a whole bunch of stuff. SF Jazz Center, the Fillmore, and yeah, we have some locations right here: Ferry Building, North Beach, and Fillmore, which are all 3 awesome music places to get some live music. And they did a great job. I really like this event. So what I'm gonna do is I'm gonna actually move on to the next step, which is making an account. Cool thing about this app, everything's run locally, even the authentication. We're using super token, something like that. What we're gonna do next is we're going to do a Golden Gate Park tour walking, and we're gonna go ahead and publish that. So and you can see we have this huge Golden Gate Park tour all made. We're going to view itinerary. We have tons of stuff here, tons of things to do here. We're exploring it. It's going to take about 2 hours and 47 minutes. You can share it on social media. You can edit it. And what we're going to do here is we're actually going to save it now that we're a user. And we're going to call it a GGGP tour. And we're going to save. Now that it's in our save list, we have here. And we're going to spruce it up a little bit. Since we have such excellent GPU power, we're going to go ahead and generate us a image. Okay, and you can see we got some images here. Save changes, go back. And you can see we have our GGP tour right here. Everyone can come see it. Right here, GGP tour from us. And yeah, there you go. This app pulls in local events as well. It pulls in, we use Nemotron to scrape the internet on local SF events. And I'm gonna pass it off to Greason to
go. Okay, I wanted to emphasize that all of this that we have built has been running entirely locally. We have a vertically integrated stack that is running everything, including the authentication, the LLM calls. Everything is done on Box, which is amazing, on the DGX. I want to emphasize the full diagram. So over here we can see that we end up having the user inputs that ends up getting processed by the system prompts. And then we are using, that is hitting a RAG database, which is being hosted through Postgres, and we are getting an LLM response from that. And we are also using Lane Graph to end up providing more tools, including a route tool, which helps us do map visualization. So we also ended up finding a specific problem that we tended to run into quite often. We ended up having the RAG fetching a lot of data, but we noticed that the LLM tends to spit out quite a couple of hallucinations based off of the data that it gets. So it might end up giving wrong information about either the address or descriptions. So we needed to create something that would appropriately eval our LLM and for these specific hallucinations, and we need to update the model or system prompt in order to better use these. So for our solution, what we ended up doing is we implemented a JEPA watchdog in a sense, which ends up allowing us to optimize our system prompt. In a high level sense, we basically end up parsing those past LLM responses from Nemotron, and then we use a JEPA mutator with a database verifier that we wrote, and basically by using this and running through multiple iterations, we can end up getting an optimized system prompt, and that optimized system prompt is happening on a cron job. So this is constantly dynamically updating, which is similar to a reinforcement learning kind of task, right? So in a sense, we are kind of doing reinforcement learning. At the same time, I kind of